Great. Hello, everybody. Thank you for joining our training event about research subject quality assessment. It's great to have people that really express their interest in joining this event that combines, in fact, two different projects for which we are creating the training activities, so ENVRI-Hub NEXT and EVERSE. So our trainers for today are Miguel Viana, João Machado, and Zimin Zhao. They have both a background in software engineering for research. And about me, it's Eleonora Parisi. I'm going to be your facilitator today, and you are more than welcome to reach me through the Zoom chat, directly or privately. And for your safety and comfort, today we are applying the EVERSE code of conduct. So just let me read out loud the key points of the code of conduct. You are invited to use a welcoming and inclusive language, to be respectful, of course, of different viewpoints and experiences, and gratefully accept constructive criticism and assume others are acting with a positive intent when unsure. We want you to focus on what is best for the community and show courtesy and respect towards others, address, acknowledge everyone equally, and ensure everyone has an equal opportunity to make comments, to ask questions, and to voice their opinions. And finally, please use social media responsibly, respecting both individuals and the other organization hosting the meeting. So as you might have noticed, this event is being recording. We're going to record the first hour of the event. So now you know who your trainers are, you know who am I. But you would like to know perhaps who else is in the room with us today. And these is like the screenshots of until the very last minute of the registrations that we receive. And it's very nice to notice that more than half of the people, as expected, are coming from environmental sciences. So they do have, of course, a background in environmental sciences, because one of the projects that is also in the training event is ENVRI-Hub NEXT. ENVRI, as you might know by now, is the community for all the research infrastructure working in environmental sciences. And this was expected, but it's very important to also notice that the people coming from with other types of scientific background, including social sciences, physics, astrophysics, and life sciences, are with us in the room, and there is indeed diversity also in the location from which you are joining today. So let's moving to the very agenda. What's on the menu for us today? The first hour is dedicated to the presentation of our trainers. So we are introducing the framework of the EVERSE project about the research software quality assessment. And then we are moving into the use case of the ENVRI-Hub. You can post questions in our Zoom chat or through the Menti. Is a Mentimeter wall. I think my colleagues are putting the link in the chat as I speak. If you prefer to talk, just raise your hand, and we are opening your microphone at the end of the presentations and answer. And then for those who express their interest in play with us also with the hands-on exercise with your code or with the dummy application that their trainers have prepared for you. In the second part of the event, starting at 12, we are going to split ourselves into more or less two groups and work on the codes, and then we will wrap up. So for me, this is it, and I'm very happy to pass the floor to my colleague and Professor Zemin Zhao for the presentation about EVERSE.
Thanks, Elena, for the nice introduction. So I'm going to share my screen first. And let me first check, can people see my screen?
Yeah, all good.
Okay. Good morning, everyone. I'm Zemin Zhao from University of Amsterdam, and also I'm from the LifeWitch Virtual Lab Innovation Center, also in Amsterdam. So today I'm going to give you an introduction to the EVERSE framework for the research software quality assessment. So nowadays, all of us know the importance of the data in the research life cycle. We use data for building models, for obtaining insights. Very often we forget the importance of another important asset, that is software. Without software, the workflow automation, the computation of the simulation models, and AI training, many things would be impossible. So in this short talk, I will explain you what is research software and what is EVERSE, and what is the quality of the research software, and what will EVERSE offer. So research software can be seen from many different angles. One way to see that is so-called inclusive view. In an inclusive view, you could say any kind of software which is used in the research activities, and any kind of software which is produced by the research activities can be called research software. And that also includes the related tools. For instance, if you are using a genetic purpose tools for obtaining data for controlled sensors, and also the programming tools like Python you're used in creating the software, these can all be called research software. This is just one way to see what is research software. But this scope becomes very broad. So there is another view to see what is research software, which is so-called exclusive view. And in the exclusive view, we only refer to the software which are developed with a clear or explicit intention for the research purpose. So the software itself is also a contribution to science and research. That kind of software can be called research software. So for this kind of exclusive use research software, and you could see this is a software closely embedded in a research life cycle, connected with the research activities. When you have a research question, and you start to formulate a project, which could be a thesis project for the bachelor, master, or PhDs. It could also be, other kind of grounded projects. And from that time on, you start to plan how, the research software should be developed for what purpose. And then you move to the next phase, to develop the actual content of the software, following the normal software engineering practices, where you could use, version control, you could use continuous integration, continuous, deployment, CI/CD pipelines, and a test software. And afterwards, you deploy it on the infrastructure to do full-scale experiments. And when the experimental result is obtained, validated, you write a paper to publish it. From the moment you publish your paper, nowadays it's also a common practice. You upload your software, make it as artifacts, make it also available to the audience to read. After the paper published, you also deploy your software. If the tool becomes very useful to the community, you make that software deployed as a services, and which can be accessed by broader users through a certain infrastructure. And feedback can be collected when the users start to use it. And those feedback could also be brought back to the development life cycle so that you could continuously improve that. So this is, one way to see how research software in exclusive view, embedded in the research life cycle. And in this cycle, you could see clearly there are many different types of research software were developed. Some research software probably will not, move to the phase like operational surface. Some of them probably only stay in the computer of the scientists. Depends on the purpose and the scope. So there is also a way, to classify those different research software through different tiers. And 3 tiers view is a typical way, people use in this community. So all the research software are the software developed on top of certain foundation software. Foundation software here refers to, for instance, operating system, database, or more generic framework like Kubernetes. These are all can be seen as foundational software. So there you have 3 different tiers. Tier 1 is analysis code. These are the code scientists write for instance, for plot results using a few lines of Python code. Those could be in a Jupyter notebook. Yeah. And after these analysis codes and maybe some kind of pipeline becomes standardized, and that could be further developed as a tool. For instance, in the ENVRI context, if you have a certain steps standardized for calculating the data for calculating ECVs, yeah, becomes a template for the workflow that can be seen as a tool. And furthermore, if the research software becomes a kind of foundation which can be used for broader users, and then people can even do further development based on that software, and that is so-called research software infrastructure. In the ENVRI context, you could see ENVRI-Hub NEXT, ENVRI-Hub. Yeah, that is a kind of software infrastructure. And you could also say virtual research environment. That is also kind of a software infrastructure. Clearly, you could see the abundances for the different tiers. Yeah. You could see a very large collection of these analysis code, but only small subset of them, or only small number of these software becomes research software infrastructure. And of course, the reach to the number of audience, that is also opposite. Yeah, research software infrastructure, usually because it has high impact and it's more important to more users, and it can reach much broader a number of users. So EVERSE basically is a kind of network, try to aggregate the practices from different communities, how these communities develop the research software, how to manage the research software, what is the practices, yeah, to curate the software and then make them as reusable artifacts, published as a research object. So all these practices are going to be collected and make them shared and make them accessible to the communities of the research software engineers. And ENVRI is one of these clusters, included in the EVERSE project. And EVERSE, of course, also connects other communities like RDA, European Open Science Cloud, and then collect these research software practices from even broader communities, and try to the vision of the EVERSE is to build a kind of framework for research software and code excellence, and then try to build a kind of network so that the research software engineers can share their practices and also learn how these practices can be included in their daily practice to serve the end user, to serve the scientists. This project have 19 partners, and 3 years project is funded by Higher Europe. In this consortium, University of Amsterdam and University of the Salento represents every community. And University of Amsterdam specifically, is also responsible for delivering case studies in the EVERSE project, act as a bridge. We try to bring ENVRI-Hub development through ENVRI-Hub NEXT project to share the best practices of how every community manage the development processes, how to control the software qualities for different stages, how did we manage the operational service of the ENVRI-Hub. And also we're going to look at the Jupyter Notebook, how the ECV workflows is developed or going to be supported through ENVRI-Hub on the analytic framework in the ENVRI-Hub framework. And then try to bring the practices from EVERSE, and implement them as a kind of plugins in ENVRI-Hub and make them available through the Hub interface, so that our developers from the ENVRI communities could get benefits from this project. So what is software quality? Yeah, that becomes another important question. Before we look at the research software quality, first we have to see what is the quality in general for the software. So there are many standardization bodies, including ISO, has looked at it. So basically, software quality can be studied through kind of things like called quality model. Yeah, quality model is elaborated by a set of quality characteristics, and the quality characteristics can be further. For instance, these are the examples defining the ISO, like functional sustainability, performance efficiencies, compatibility, etc. And those characteristics can be mapped onto observable metrics Those observable metrics can be quantified through certain tools to measure what these characteristics actually look like. And to manage the complexity of these characteristics, in many cases, you could divide one characteristic into a set of sub-characteristics, or you can group them, together as a kind of quality dimensions. In the EVERSE project, basically we use this as the basis and also learn what is the different characteristics defined by ISO standards and choose to select the best ones which fit the research software context. And so EVERSE research software quality model, it has a set of dimensions, quality dimensions, and those quality dimensions at the moment, we have 9 of them. 9 of these dimensions are derived from the ISO quality characteristics, including compatibility, flexibility, etc., until your safety, security. These are the 9. Besides that, EVERSE also identified 2 important dimensions for research software specifically, which are not part of ISO. One is fairness, the other one is sustainability. And using these quality dimensions, we can define some kind of measurable metrics. In EVERSE, we call those metrics as indicator. An example could be for the fairness. The fairness of the research software could be measured through the indicator of the completeness of the code metadata. And another example could be related to the security. You could say, to measure the characteristics or dimensions of the security, we could use the indicator of the vulnerability, how the critical vulnerability, is checked in the code, or the leak of the credentials in the code as an indicator. And those indicators eventually will be, assessed through tools. So what EVERSE is going to provide us, so basically is a kind of, one way is the portal. So that portal will collect these dimensions and the indicators definition plus the set of the tools, and then make them through a kind of, a network environment. So all the participants of the EVERSE network can get access to these tools and get access to the definition of the quality dimensions and the quality indicators, and to learn from each other how the tools can be applied to measure those quality dimensions. And of course, this is an ongoing process. At the moment, only small number of indicators have been defined. Maybe during the projects, the number of dimensions can still grow. Number of indicators, of course, will also grow, and the tools will be updated. This will be the community effort. At the moment, EVERSE has a group of the experts reviewing the best practices, which collected from different clusters, and then make a selection there. And so in this project, the ENVRI-Hub NEXT project is an active partner there. Through the ENVRI community, we're bringing the use case of the ENVRI-Hub framework. We try to apply the practice from EVERSE and the pipeline for delivering the service of the ENVRI and ENVRI-Hub to the operational infrastructure. So in the next talk, you're going to hear more about the current practice, how ENVRI community did through the CI/CD pipelines by adding different quality control tools to manage the pipeline there. And we're also going to develop some kind of tools based on the indicators, based on the guidelines provided by the EVERSE, to make them customized for the things like the Jupyter Notebook quality control. This is also ongoing activity within the ENVRI community through University of Amsterdam. So I'm going to stop here. So I hope this gives you a quick introduction, what research software quality is and what EVERSE can offer us. So in the next part, you're going to hear more about the current practice, of the ENVRI, and to see how current ENVRI community, controls the software quality through the CI/CD pipelines. Yes. So are there any, burning questions? Otherwise, we can, answer, more questions until the end of the next lecture. We can, discuss them together.
I think we have Clement. We cannot hear you, Clement. Let's see. Microphone is on. Yes, we can hear. Not yet.
No, I didn't hear anything. Maybe
Okay, maybe.
we could just move on and then, leave the question until
Indeed.
Yes.
Yeah.
Okay.
So just quick reminder, you can write your question in the Zoom chat. And also we have, for more complex question, we have the Mentimeter wall. We can move on with the presentation by Miguel.
Okay, I'll share my screen. Yes. Maybe it's this one. Can you hear me, right? Oh.
Yes.
Okay. So, hi everyone. So for this second presentation, we'll take a look on the ENVRI-Hub use case, specifically focusing on how we currently assess the software quality some of our applications. During this presentation, you can, as Eleanor already said, submit your questions using the link or just scan this QR code. And also feel free to put there your questions. So hopefully in the end of this presentation, we can address all of your questions. Let me start by doing a brief presentation of myself. So I'm Miguel Viana. I work for LEAP and CNCA for more than 5 years, where I started as a Linux sysadministrator and in the context of HPC, and then I made the shift to work as a cloud engineer, which is what I primarily do now, alongside with cybersecurity. And of course, because no man is an island, I'd like to also introduce Jean Machado from CNCA. He's also a cloud engineer and a key part of our work on these cloud native matters. And for those of you attending the hands-on session later, you'll get to work with him directly in the second part of this training event. Here's our agenda for today. I begin by presenting to you the ENVRI-Hub applications ecosystem, its challenges, and some solutions we found. And then we'll take a look at the application development lifecycle. And after the coffee break, you'll have the opportunity to try these tools. I'll present here and see them in action. Starting with the ENVRI-Hub applications ecosystem. With so many diverse applications spread across multiple Git repositories, developed and maintained by multiple different teams, it becomes more difficult to build, check, and deploy all the applications properly and in a consistent way. Plus, initially, we also lacked for standardized ways to check code quality or scan for security issues. And all of this increases the operational costs to deploy and manage those applications, those application deployments, and impacts negatively on our security posture. Our solution was to create a standardized and easy way to address all of these issues by creating a CI template. And with this, we allow development teams to check their application source code before they try to deploy them without need to know in depth which tools to use and how to configure them. And in a side note, let me just tell you that I truly believe that we, the DevSecOps teams, should always try to do our best to offload all of these operations and efforts for development teams, so developers can focus on software development and don't need to dedicate their time to become specialists on these matters. And with this approach, this approach allows to implement and enforce some software quality assessment baselines against the source code. And even the containerization operations are performed through pipelines. And lastly, we can also infer about the project's compliance with the FAIR principles. And of course, with this approach, we improve the overall application quality and reliability. The deployment cycles are also faster, and the operational efficiency is improved by considerably reducing the manual efforts of this process. And naturally, all of these improvements also enhance our security posture in general. Now, let's take a look on a representative timeline which shows us all the stages in the ENVRI-Hub applications deployment.
Miguel, I'm sorry to just very quickly, could you try to put your headset on, because your voice is like varies in volume. I do believe it's because of the position of your microphone. Could you try whether there is an improvement?
Yeah, let me try to put here.
Yeah, now it's definitely better.
Okay, sorry. Okay, now you can hear me well, right?
Yes, thank you.
Okay, if you want to me to repeat something,
No,
I said
everything.
earlier.
No. Yeah, please move
Okay.
on. Don't worry. Yeah, but now
Okay.
it's definitely better. Thank you.
Yeah, thank you. So, anytime a commit is made to a certain Git repository branch, the pipeline is triggered and start by performing a software quality assessment on the source code. Both the new code, which was introduced or modified by this commit, and also the overall repository. And then we proceed to the containerization part, which we'll look in more detail after. And then we proceed to create or update the Helm charts, which allows to deploy the application in multiple clusters and environments. And lastly, we proceed with the deployment on validation and production environments. And these two last steps will not be covered into much detail in this presentation, since it is quite a bit out of the scope of this presentation. Starting with the software quality assurance. As previously said, anytime a commit is made to a certain Git repository branch, the pipeline is triggered and start the software quality assessment on the source code. For the software quality assessment, we adopt the SonarQube tool. This tool is an open source platform which allows to analyze the source code to identify errors, bugs, issues, duplications, and security vulnerabilities. And SonarQube also provides a great integration with the most popular IDEs and CI tools, as we'll see later. Now, some relevant SonarQube features. It offers analysis for more than 30 programming languages, which he also detects automatically. It can also detect different types of bugs in the source code in the source code that can cause the software to behave unexpectedly or even crash. For example, here in this code snippet, instead of adding A and B, you accidentally are subtracting A and B, so the result will be not the expected. And SonarQube would spot this bug and tell you that the addiction is not working as expected, and it will suggest the changing to fix this bug. SonarQube can also detect weaknesses and flaws and security issues that may represent a backdoor for the attackers. For example, imagine that you are building a login system for a website, and if your code doesn't properly validate user input and leaves room for, let's say, SQL injection, so attackers could manipulate the input and gain unauthorized access to sensitive data and so on. So these are the kind of issues that SonarQube warns you. And it also looks for hard-coded sensitive values, passwords, tokens, and so on. Also regarding code smells, SonarQube can also look for characteristics on your source code that indicate the possibility of a problem caused by your code in the future and maintainability related issues on your source code. In conclusion, SonarQube allows automated checks to ensure the source code to ensure that the source code meets the standards for maintainability, reliability, performance, and security. And also it allows you to prevent and detect issues in early stages of your development. Once inside the SonarQube UI, which is represented in the left side of this slide, you are presented with a brief analysis overview for each project, which is being assessed by this tool, and of course, which is visible for you. And this includes a brief overview about the number of bugs, vulnerabilities, code smells, coverage percentage, and application percentage for each project. SonarQube provides support, native support to integrate with the most used CI/CD pipelines from platforms like GitHub, GitLab, Azure DevOps. So there will be not too much painful to integrate your CI/CD pipeline with SonarQube. Also, you can install the SonarQube extension in your IDE, and it will provide you real-time code analysis and feedback within the IDE. And it will help you, developers, to identify and address code issues early in the development process, even before you commit your source code to the GitLab repository or any other platform, and wait to run the pipeline. So you'll be getting warnings in live while you are coding. Of course, alongside with SonarQube, there are a lot of similar issues, and there is also another relevant tool called SQA, which stands for Software Quality Assurance as a Service, or Assessment as a Service, which is a project within the EOSC synergy, and it also performs static code analysis, code coverage, etc. And also integrates well with the principal CI/CD pipeline platforms. And for those of you who are interested in these topics, I highly recommend you to explore it. Next, going to the containerization phase. To create a container image, we integrate it into the pipeline tools such as Canico or other similar tools, which doesn't depend on Docker daemon to build images and executes each command completely in user space. And these are hootless solutions that will produce a Docker image, and in case it passes on vulnerability scannings, those images will be published and deployed later in different environments. Okay, but I think okay, yeah. So after building a container image, it's crucial to perform some vulnerability scans to look for relevant CVEs on the produced Docker image and find forgotten sensitive data such as keys, tokens, and so on. For these vulnerability scans, we use the Trivi tool, which is an open source and free solution, and it's quite good on this container vulnerability scanning. Also, let me tell you that, yeah, we did first the quality assessment on your source code, and now we are doing the quality or security assessments on the produced Docker image. And the difference is that while in the first step, we are only checking your source code, here we are also scanning your base image or the yeah, the base image, the base container image you are using to create your own container. So we are not doing the security assessment to the same source code. Okay, it's different scopes. This is an example of a report produced by Trivi where you can find where you can check for the CVEs present on our new Docker image. We can have some information about the severity of each CVE identified, a brief description of it, and in some cases also the fixed version. So it's easier for you to fix all of these findings. And of course, you will interact with and see this tool in action in the hands-on session. Trivi is also allows for some more advanced scans, such as the creation and handling of SBOM, software bill of materials. If you want to go deeper in the security of your container application. After a new and secure Docker image being produced, we need to publish it in a container into a container registry, so we can later deploy it elsewhere. There are two types of container registries: the private ones, which allows you to control the access to your container images, and the public ones, where everyone has access, at least to pull the Docker images. Just a side note, in GitLab platform, at least each GitLab project has its own container registry, which can be public or private, depending on the scope of your repository itself. After having a Docker image ready to use, it's time to deploy it. And on ENVRI-Hub, we use Helm charts to deploy our containerized applications. Helm chart is a tool which allows to collect all Kubernetes resources required to deploy a given application into a single package. And by taking leverage of templating functionality of Helm chart, it allows the deployment of the same application across multiple environments and clusters with environment-specific configurations. This approach, of course, simplifies the deployment and allows customizable deployments with less efforts. Also enables version control and rollbacks in case of deployment issues, etc. Naturally, all of these Kubernetes resources files are also assessed against some set of rules to ensure secure and compliant Kubernetes deployments. On the right side of this slide, you can see some of the Kubernetes-related CWEs, or common weaknesses enumerations, that are scanned. The last stage in this pipeline is the deployment. And by using the Helm chart created or updated in the early stage of this pipeline, we can deploy our applications in multiple clusters and environments in a simple way. As I mentioned before, this is not this part is not explored in detail in this presentation. However, of course, feel free to reach me out after this presentation if you want additional insights about this topic. Okay, now it's time to check your questions. I don't know, Eleonora, if we have some, both on chat or Mentimeter.
Yes, we do. We do. I would start perhaps with the question that was, I think it's for Ziming. So since we know that Ziming is going to leave us during the second part, the question is, will the quality indicator, and here we are talking, of course, about visual software.
Right. Yes.
Will the quality indicator provide a metric to assess how good a software project adheres to the best practice? For example, 5.8 out of 4.8 out of 5.
So At the moment, the open source project is highlighted as one of the dimensions. But since it's in the very beginning, this was highlighted as a dimension, but later it has been broken as different pieces in different places. For sure, I think software project management will be included in one of these dimensions and assessed through some indicator that. But I think that so far we only have 4 indicators published on the EVERSE website. I think in the coming phases, these will be, covered by, the coming ones. So the answer is yes, but we don't have it now.
Okay, next question. For Miguel, very straightforward. Miguel, what is this CNCA?
Yeah, sorry, I was muted. Yeah, CNCA stands for it is a quite new. It was rebranded, so Advanced Computing National Center. So it was before it was called INCD, which stands for Distributed Computing National Infrastructure.
Okay, question by David Correa, because I saw it on the Zoom chat as well. So do you plan to present the usage of Argo CD and good practices to deploy application in a Kubernetes cluster? That would be very interesting too.
Yeah. For a 40 minutes hands-on session, it would be quite difficult to explore all of these quality assessment topics and the deployment topic in the same session. So I would like to, but it's quite difficult in 40 minutes to do so. But I'm completely available to maybe schedule a new training event just to focus on the deployment part. I think it would be very useful, but yeah, for a for 40 minutes of hands-on session, I don't think it's feasible, but I would like to.
Okay, great. So not for the future training, and for sure there will be opportunities indeed to organize. Another question, what tool are you using? So again, for Miguel, what tool are you using for CI/CD to scan the help charts to search for security issues and vulnerabilities?
I need to check the name because that's a lot of tools, but it is kubectl. I will paste in the chat in a few seconds.
Great.
Because I need to check. That's a lot of tools we use, so I don't remember all of them. But yeah, I'll definitely send you in the chat in a moment.
Great. So a follow-up on SonarQube. How does it find bugs? Is AI used?
Sorry, I was no. That's a lot of predefined quality gates, which have some predefined rules, which are used to assess your source code. Of course, you can add more, but there's no AI by default. I don't know if there is any integration for that. As much as I know, I don't think so, but maybe in near future there will be, but SonarQube works mainly with quality gates, which defines for each programming language a set of rules that will be assessed against your code. And these rules are based on CWEs, CVEs, and so on.
Okay. Right. This is a general question. I guess maybe Zimin could take this. Are indicators for fair software well-defined?
So there is
Great question.
there is a quite big community behind this verification for research software. So in the EVERSE, at the moment, there is just one indicator defined for the it's called meta code completeness. I would assume there will be more and more indicator included in the toolkit. Yeah. In the EVERSE, this is called a research software quality kit, ISQ kit. Yeah. So probably you should subscribe to our network and check that. Yeah. Thanks. It's a good question.
I think there are other questions for Miguel. Yes, for example, how do you see metrics on CD SonarQube?
What do you mean with CD SonarQube?
Whoever posed the question, perhaps if who wants to follow up, can open the mic or just include the other details in the chat. Or for the time being, we can move to another question and give the person who wrote who wrote that the time to give us a follow-up. So other question for Miguel is, how do you include SQA, AAS in the application development pipeline? I'm not aware that it has a public API, and I could not find an SQA AAS plugin in the Jenkins plugins index.
Yeah, as much as I know, SQA provides a pipeline template to integrate with GitHub Actions and GitLab CI pipeline. So you simply need to import this template, and your project will be sent to the SQA instance, will be assessed, and the report will be returned to your CI tool. For SQA, I'm only in the user side. I'm not into too much details about the development side. But as much as I know, there are some problems with assessing private repositories, but for public repositories, it will work like a charm. So you simply do the import of the CI pipeline template they provide to you. You integrate it with your already existent pipeline, and it will work. I already tried it before.
Okay, do we have another question? I guess this is for Miguel, a follow-up on SQAS. What are the sustainability plans for SQAS? I use it in another EU project and need to know that it will be available and maintained for at least the lifetime of my project.
Yeah. Of course, this is a very relevant question, but I don't have the answer. Maybe I can provide you an email with someone who is directly involved in this project, in the development, and he will know better than me how to answer this question. As much as I know, the project is still being maintained, but of course I don't know too much more details about that. But I'll provide you. I'll paste in the chat an email to contact directly one of the main persons behind the development of this project and maintainability of this project, so you can have a more detailed answer.
Yes, thank you, Federico. Your spot. A question from Uli in the chat. So since we still have time. Will we merge both word EVERSE and SonarQube?
I think maybe I can start start.
Well,
I think the developers and it's in the research software communities for sure they are using different techniques, different practices. So EVERSE as a network, I would say it is open to the members from different let's say the communities, whether this can be merged or not, or maybe just already connected. To me, I think it's probably the better way to formulate is these two words already connected to some extent.
Uli, do you want to add any details? Like what
Yeah,
exactly
the fear
meant?
is that we'll have two worlds, and that to apply two independent CI/CD pipelines with software checks and so on might be complicated. And I think we have to merge both worlds.
Yeah, so the EVERSE actually is aimed to provide different tools and practices. In this case, I would say, SonarQube, including other types of techniques, will be recommended by EVERSE through its ISQ kits.
Okay.
Then, people can decide which one to use based on their own situation. So that's what I mean. These communities are already connected. Yeah.
Okay. Perfect. Thanks.
The ICD is going to be a highly customized environment for each different project.
Okay, I think another question. Okay, yes, we can take another question. Thank you. Is everybody on the everybody on the call DevOps? Is everybody aware what SQA, AAS, Jenkins, etc. are? Okay, thank you for posing this question. This is for everybody in the room. So I can reply very quickly because I saw the information of all the registrants. So definitely not everybody is on a DevOps specialist. Many of you, of course, have software engineering, research software engineering experience for different point of view. But of course, you are free to add more details if you want in the Zoom chat. And I believe that in the second part of this training event, after we are going to split in the working groups, they're going to be, for those that are indeed doing the hands-on exercise, there's going to be also an opportunity to quickly present ourselves. So you are invited, of course, to share about your backgrounds as well. But for those who are leaving, if there are not other burning questions, of course, and Federico help me if you
Sorry,
see anything.
Eleonora, can I
Yes.
add something more
Of
to
course.
your answer? So yeah, for those of you who doesn't know what is Jenkins, SQA, and so on, and all of these tools and terms we were talking about in the last hour, let me just reinforce what I said previously. In my personal opinion, I don't think that developers need to know too much about all of these tools and terms and techniques and methodologies and so on. So it is just to give you an overview how we can do some checks on your source code and what happens once you commit some new code to a GitLab repository, and also to you to know how to interact in a developer perspective with those tools to interpret the results they produce. It is not expected to you developers to know how these tools works and how to configure them. We, as DevSecOps teams, are responsible to provide you simple ways to integrate within your GitLab repositories or any other kind of source code platform to do those assessments. Okay, and for those of you who will be on the hands-on session, you will see that it is everything prepared for you to use. You just need to do some commits and interpret the results from these tools. Okay, you don't need to worry about how these tools works and why this tool and not that tool. You just need to get inside the UI and it will tell you, okay, you have an issue here. Why this is an issue? You have here the explanation and how do you mitigate this issue. And also you have their explanation. It will be more intuitive for you in the hands-on session. Don't worry.
Miguel, just if you can add also a follow-up to what just Simon asked in the chat. So will it make sense to participate in the hands-on part as a software developer? I would
Yeah,
say
definitely.
yes.
Definitely. So you will know a little bit more what these tools produces once they scan your source code, how to interpret these results, and how to fix it. It is not a hands-on session for you to know how to mount all of these solutions and do the interoperational stuff between those tools. No, nothing of that. You just need to go there and push some code and know how to interpret this code, this source code. So yeah, definitely this is more designed for developers than any other kind of rules.
Okay. So before we go to this, we move to the second part. There are some people who are going to conclude here their learning experience. So let me share for them what's next. Meaning, of course, we want to know how this training event went. Well, so far for you, I'm going to send the post-training survey to everybody who registered. For those who are not participating in the second part of this event, it's already possible. I would say you are encouraged to reply to the survey. Then another thing that we encourage you to discover, it's more about the EVERSE project, in particular the events network. Something that we didn't clarify at the beginning is that this event is part, of course, it's a joint training event between the project ENVRI-Hub NEXT and EVERSE, but in particular it's also part of a webinar series organized in the context of the project EVERSE. And this is thanks to the fact that EVERSE is really providing a service of creating a network for research software developers, for scientists interested in research software quality in general, scientists that are welcome from all kind of different science clusters, not only an environmental one. So next month, you will have another episode of this webinar series, in particular on Wednesday, 11th of June. And the webinar is going to be about Compute and Accelerator Forum, Julian and GPUs. And you're very welcome to register already. And then we're very happy to launch the brand new EVERSE network, Mattermost. Mattermost, for those of you don't know, it's simply something similar to Slack. Is a workspace where you can create a working group, different channels, thematic one, and you can chat and among the people that can and are very welcome to sign up. And then, of course, for those of you who are really curious about the possibilities offered by the ENVRI-Hub in terms of data discoverability and data analysis, you are very welcome also to sign up to the user groups of ENVRI-Hub, because in doing so, you will have the opportunity to discover beta users before others, the new features, as long as ENVRI-Hub NEXT release new parts and new services of ENVRI-Hub. So let me check in the chat. I hope that somebody. Yes, thank you, Sonia, for posting the link to the network. And let me also remind everybody that you're very welcome to join the AGI 2025 conference taking place in Santander in Spain in between 2nd and 6th of June. We are going to have AGI booth and ENVRI-Hub Next in particular is going to be represented there. So I would say that, as somebody has asked, we are going to have yes a couple of minutes break.